You know, you're at night outside, and your pupil opens to collect enough light that you can get a picture. Huh? So this collecting area of the pupil determines how much you can see under dark conditions. When you switch on the light at night, then your pupil goes back very quickly to a small size because there's enough light. So when you want to observe faint objects, faint things in the sky, you need a big pupil. And the big pupil is exactly the mirror size of a telescope. That is the collecting power of the telescope. And so when we have a SALT telescope of 10-meter diameter, then you're collecting huge amounts compared to a few millimeters of your pupil. And that explains why we can see with these telescopes very, very faint objects that we don't see with the naked eye. And so you have, when the light comes from a star or from a galaxy to your telescope, you need you need to bend the light to bring it to a focus point. And you have two options. One is that you have a lens. The light goes through the lens and gets focused onto a point. Or you have a mirror, like a shaving mirror. It's slightly curved. It goes down onto the mirror, the light, and gets bent. And then sometimes you have a second mirror, and it gets bent again and goes through at a particular position where you have the detectors. So it's just collecting all the light from this big bucket, from the mirror, collects it into a spot where you can set up your instrument and record the flux from this. Now they are historically, you had lens telescopes because it was difficult to make surfaces or grain surfaces to a certain specification. So you have lenses. The difficulty here is when you get to really big lenses, even 1 meter diameter would be already a challenge. You have a 1 meter diameter lens, would be very thick in the middle, very difficult to produce, and all the weight of the telescope would be at the top, which makes it quite strongly affected by the wind. So that makes it really, really difficult from a technical point of view. And so it's not a surprise that then people, once they were able to polish surfaces accurately, that they moved to this second option where you bend the light with a curved surface. And all the big telescopes now, they're in the world, optical telescopes, they're all having the same principle. You have a surface polished, and that surface reflects the light to the instrument at the end. So there are almost no lens telescopes, refractors anymore in the world.